Okay. Okay, so we're gonna be dealing with polygons for chapter 8. So it's a lot of formulas. Pretty straightforward. Just have formulas, apply the formulas. Now, there in terms of shapes, it goes past 10. So for an 11-sided shape, 11-sided polygon, it is called a hectagon. So a decagon. In terms of this class, we won't go past a 10-sided figure in terms of the names. When you get to math 3, you do end up getting more names. This is considered a dodecagon, so just a couple names. Um, so a quick thing to note, anything over 10-sided figure, so over 10 sided figure. Luke, if you can't be quiet, I have to move you to the front. Luke, Max, over 10 sided, oops, sorry, over 10 sides, it will have the number of the sides and the gon at the end. We'll have the number and gon at the end. So for example, a 13 gon is considered a 13-sided polygon. In math, we like to give names to a lot of stuff, but then there's just like we get to the point where we kind of run out of names. So we just write the number and then we put a hyphen and we call it gon. Okay. All right, let's start with number one. Well, actually, before we get to that, okay. So the polygon interior angle sum theorem. So the sum of the measures of the interior angles of a convex polygon is 180 times n minus 2, where n is the number of sides of the polygon. So this is for any type of polygon. If you want to know what the sum of all the angles, so angle A, angle B, angle C, angle D, and then angle E. If you want to know what they all add up to, you take 180, multiply it by the number of sides, minus 2, and you'll get 540. So N in this case is the number of sides. So in this case, this is a five-sided polygon. So that means we're gonna add 5 in terms of n, subtract 2 times it by 180, we get 540. So that means they all add up to 540 degrees. The next theorem you have to know is the polygon exterior angle sum theorem. So the sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360. This is very important. So it doesn't matter what kind of figure you have, the exterior angles of the polygon all add up to 360. It does not matter what kind of polygon it is, it will always add up to 360. Now, this is for the angles on the outside. So this is a four-sided polygon, and then you can get the exterior angle by just extending it, and then you can subtract it from 180, and you'll get these angles, and they all add up to 180. All right, so this is a problem. So for number one, it says find the sum of the angle measures of a nanogon. So this is for so we'll just use the formula. Now, the thing you do need to know is how many sides does a nanogon have, which here I says look at the last page and I'll give you a little cheat sheet to determine what the name is and how many sides it has. Now, it doesn't matter whether it's regular or non, um, they follow the same number of sides. So in this case, if you look at it, a nanogon has 9 sides, so that's pretty much the hardest part of it, is knowing that it has 9 sides, and all you have to do now is just plug it into the formula. The number of sides. 9 minus 2 is 6. Use the calculator, multiply it by 180, and you should get 1,260.
Oh, okay.
It is 7. 7. So that means this is wrong, which gives me. You guys are smarter than the last class because the last class did not fix this mistake. Because I'm looking at my notes from last year and no one actually. Wait, is it 1,260? Yeah. Okay. I wouldn't recommend you telling that to the other class. So.
I understand you said.
All right, so that's number one. Find the sum measures of a nanogon. So when you add all the angles in of the inside interior angles of the polygon, it will be 1,260. Number two, find the measures of a quadrilateral. Now, this is not in your cheat sheet, but you guys learned about quadrilaterals last year. Does anyone know what is a quadrilateral, Max? Yes, it is a square, but it can be a rectangle or it can be a kite or it can be a rhombus. It is a four-sided shape. Very good. So n is equal to 4. So this is what I mean about naming the actual shapes, either one the cheat sheet or from the stuff that you learned from before. So 180 minus 4 minus 2. Not 40, by the way. 4 minus 2. You should get 360 degrees, but very good. I hope it is because we're barely on the first section, so it has to be easier. All right. Number three, find the angle sum of measures of a 14-sided polygon. These ones are the easy ones because it already tells you how many sides it has. It's literally the number that's in the front. So all you gotta do, 180, 14 minus 2. 2,160. All right. Shh. For number 4, find the sum measures of a dodecagon. So in this case, this is a 12-sided figure. Oh, this is the reason why I actually gave it to the last class. So dodecagon is a 12-sided figure. Maybe you don't go past 12. It's one of those two. So dodecagon has 12 sides. 12 is hendecagon. Hendecagon. 10 is decagon.
11 is a hand.
Yeah, 11's a hendecagon. All right, so n is equal to 12, 180, 12 minus 2, 1,800.
Okay.
Okay, so 1 through 4 are pretty straightforward. It's not too difficult. Okay. Shh. For number 5, it says find the measure of an interior angle of a regular polygon. How many sides does a polygon have? Now, this is the key word, a regular polygon. So the regular polygon means that each angle is congruent to each other for the regular polygon. So it's kind of similar to the original formula. 180 n minus 2. The only difference is that for a regular polygon, you actually can find the interior angles. And you do that by dividing it, sorry, not subtracting, by dividing it by n. This will give you the interior angle. but this only works for the regular polygon. So keyword regular polygon. Since we know this is a regular polygon because it's literally in the question, we're going to use this formula to determine the number of sides. So 180 and minus 2 divided by n is equal to 176 degrees because it tells us that that's what the interior angle is because it literally says given the measure of the interior angle. And honestly, we're just gonna, what's it called? Just do cross multiplication and solve for n. So cross multiply. So when we cross multiply by 1, it's literally just 180 and minus 2. But for the 176, when we cross multiply, it's 176 times n. The left side doesn't change because you're literally just multiplying it by 1. We distribute, get 360. In this case, when you subtract 180 and you'll divide by a negative, and that's perfectly fine. So you can just subtract 180. So negative 360 is equal to negative 4n divided by negative 4. N is equal to 90.
That's a lot of sides.
That is a lot of sides. So this is a 90-sided polygon. Or in this case, this would be a 90-gon. But in this case, the only thing you care about is the 90. So for number 5 and number 6, you're going to use this formula to find the number of sides. Now, this formula is not in the first cover of the sheet, but you are going to need to know this. So make sure you write this in your 1 page of notes. All right, does everyone get number 5? Okay. Number 6, given the measure of the interior angle of a regular polygon, keyword regular, because it has to be regular, otherwise you can't use the formula. And it tells us the interior angle is 177.5. How many sides does a polygon have? So it's the same thing. 180 parentheses n minus 2 divided by n is equal to 177.5. Because that is the interior angle. Cross multiply 180 and minus 2, 177.5 times n when you cross multiply. Put a 1 underneath. And you can put the circles if you like. So that's pretty much the sign for cross multiplication. And honestly, the left side doesn't change. It's 180n minus 360. Subtract 180n. Negative 360 gives us, this one you actually have to use a calculator, minus 177.5. Negative 2.8n. And then you divide by negative 2.8. Oh, is it 2.5? Thank you. Oh, it is 2.5. What did I put in my calculator? Oh, I put 177.2 instead. 360 divided by 2.5 gives me a 144-sided polygon. Or in circle in this case, what's the rush is.
Yeah, these are kind of all the polygon.
Okay. Shh. All right, so that's for number 6. Everyone get number 6. Okay. Number 7, given the measure of the exterior angle, so keyword exterior, of a regular polygon, so the other keyword, regular polygon. How many sides does a polygon have if the exterior angle is 24? Yeah, not really necessarily. So here's the thing. To use this following formula, 180 n minus 2 divided by n, I need the interior angle. But what am I given? The exterior, right? So that means I don't know how many sides it has, but if I wanted to draw one of the angles, it'll look something like this, right? And then all the other sides. So the exterior angle in this case is 24 degrees, but I need the interior angle, this angle inside the polygon. What do you think I'd have to do to get the interior angle, Liam? Why? Mm-hmm. Very good. Impressive. That is correct. 180 minus 24. Actually, you would have said it better than I did. So that's actually really good. 180 minus 24. So that will give me 156. So impressive. That's really good. 156 degrees. So that means my interior angle is 156 while the exterior angle is 24. Now I can use the formula. So 180 n minus 2 divided by n is equal to 156 degrees because that is the interior angle, even though I'm given the exterior angle. So cross multiply one underneath. So the left side doesn't change. It's honestly just always stays the same. 156 degrees n. Distribute. I feel like I messed up. Did I mess up?
You forgot to add the 10 to the 156.
Ah, thank you. I knew I messed up somewhere. There you go. So this isn't a degree. This is just n. Okay, now that looks correct. So subtract by 180 n. So negative 360 degrees is equal to 156 minus 180. 24, thank you. Divided by 24. Sorry, this is negative 24, by the way. Don't forget the negative. So the number of sides for this polygon is 15. So this is a 15 gon. And that would be my answer. So that is number 7. Number 8 says find the value of each variable. So we got to figure out what the missing variables are. We need to figure out what y is, what z is. The easiest one, we should all know how to figure out, is angle z. If I know the exterior is 110, all I have to do is take 180, subtract from 110. Z is 70 degrees. To figure out what angle y is, I need to know what all of these angles add up to be. Now, this is not a regular polygon. This is just a polygon. This is an irregular polygon, meaning all the angles are not the same. So irregular polygon. So when it's an irregular polygon, you're going to use the following formula. 180 and minus 2 equals the sum of all the angles. So in this case, the number of angles of this polygon is 4. So 180 or minus 2 gives me 360 degrees. So now that I know what all of the angles add up to, all I have to do is just add them all up. Y plus 70 plus 93 plus 83 is 360 because that's what the angles all have to add up to. So it's a lot of adding, honestly. So 70 plus 93 plus 83 is 246 equals 360. Minus 246 114. And that is the angle Y, and we already found angle Z. Last problem, and we are done. Number 9. Find X, then any of the unknown angles in this quadrilateral. Now, is this a regular polygon or an irregular polygon? Irregular, right? Now, here's the thing. How many sides does this polygon have and the other polygon that we just did? So what do they have to add up to? 360 degrees. So technically, we didn't even have to use a formula for this because we know it's an irregular polygon. Then we know they have to add up to 360 degrees. But you could apply the formula again because technically you would have to if you didn't know it. But for an irregular polygon of a four-sided shape is always going to be 360. So irregular four-sided polygon, the sum of all angles is 360 degrees. So it's the same as the previous problem, but in this case, I'm not going to apply the formula because I already know that's going to be 360 because I did it for the previous problem. So I don't necessarily have to do it for this problem. Okay, so all we got to do now, since we all know what they all add up to, so that means angle P plus angle R, and then I'm just going to write the whole thing. Angle T plus angle S is 360 degrees. After I know what they all have to add up to, I just have to do substitution. So angle P is x plus 10. Angle R is just x. Angle T is 2x minus 5. And then angle S is 2x minus 5. So technically, those will technically be congruent since they both equal the same thing. All right, does anyone have any questions? Okay, we have to combine like terms. So in this case, we were gonna combine x, x, 2x, and 2x. What do we get when we combine x, 2x, and 2x? Very good, 6x. What do we get when we combined 10, -5, and -5?
0.
Very good. So in this case, it's just 6x equals 360. 10 minus 5 is indeed 0, so those end up canceling out. Divide by 6. X is equal to 60? Thank you. All right, so we got x is equal to 60. Now it's asking us to find all the angle measurements. So that's kind of the part kind of do a little bit of work. So angle P is x plus 10, and we know that x is 60, so 60 plus 10, 70 degrees for angle P. Angle R is just x, and we know x is 60, so this is 60 degrees. Angle T is 2x minus 5. So 2 times 60 minus 5, 115. Actually, no, it's not. Oh, yes, it is. 2 times x minus 5. I accidentally put the parentheses on the minus 5. So 2 times 60 is 120 minus 15, 115 degrees. I accidentally wrote it wrong when I did the parentheses. By the way, you're supposed to multiply first before you subtract. So do not do 60 minus 5 and multiply by 2 because that is incorrect. Then the last one, angle S, same thing, 2x minus 5. 2 times 60 minus 5 is also 115 degrees. So for this problem number 9, it's actually gonna have you plug it in. So you're gonna have to just plug in the formula, plug into the equations. Does anyone have any questions? All right, other than that, that's pretty much it. The homework is on Canvas. Give me a minute to post it. You have the rest of the block to get this done.
Oh.